Good morning, everyone. My name is Jérémie Geelen, and I'm the Market Intelligence Director of Bioenergy Europe. And I'm very happy to welcome you all today to our very first event of the year for Bioenergy Europe, organized at the Press Club to present our latest statistical report underlining the dynamic role of bioenergy in the EU's energy system. Here on this slide, you can see a complete representation of our membership basis. We have around 180 members currently at Bioenergy Europe that are divided into three main categories. So the first one are companies coming from Europe, but also from other parts of the world. Then we also have association. So those are mostly national associations from European countries, but also from outside of Europe. And last but not least, we have academia and research centers. So having such a broad spectrum of people and organization helps us get a deep understanding of what people expect from bioenergy and how we can ensure that it remains an integrant part of the future energy system in Europe. Talking about this energy system, here's a summary of what I will go over in my presentation today, which I hope will provide you with a good understanding of the sector, as well as the magnitude of the challenge that we are facing when talking about decarbonization. So I'll first start with an overview of the EU's energy system, to then dive into more details on the role and various uses of biomass, and then I will wrap up this presentation with a few key takeaway messages. But without further ado, let's dive into this presentation by going over the overview of the EU's energy system. And starting with this pie chart, representing which end use actually constitutes most of our energy demand. So we see that we have three main categories of demand, and the first one, which is represented by the yellow part, is our electricity consumption, which amounts for 25% of our total demand. Then we have the blue section, representing our transportation needs, which amount for around 26.5%. And last but absolutely not least, we have the heating needs, represented by the green area, accounting for close to half of our total energy demand. The first point I'd like to make is about the importance of heating in our energy system. So, when we talk about decarbonization, the emphasis is often put on electrification and on the decarbonization of our electricity consumption. But half of our energy is actually used for heating, which underlines how important it is to decarbonize our heating sector if we want to achieve a carbon neutral energy system. Now, using this same pie chart as a central point for my next slide, I would now like to go over the current state of our energy system, meaning which fuels we're currently using to fulfill our energy needs. And these are represented by the outer circle that just appeared on the slide. And here, the darker grayish color represent non-renewable fuels, so oil, coal, natural gas, and nuclear energy. The green color represents bioenergy in all of its forms, so solid biomass, liquid biofuels, as well as biogas. And finally, we have the light blue color, which represents all the other renewables combined, but this category mainly consists of wind, solar, and hydropower. I really like this slide because it underlines the versatile role that biomass plays in fulfilling our energy demand. Now, if we'd like to quantify our energy system, I'm going to start with the heating and cooling sector. And there, fossil fuels are used to fulfill close to 80% of our needs, while bioenergy covers nearly 20% of our total heating demand, or 84% of the renewable mix, while other renewables cover around 4% of the heating demand. This underlines the absolute key role that bioenergy plays in the EU heating sector and how trying to leave bioenergy out of any realistic heating decarbonization strategy is totally impossible. Here on the right-hand side of the slide, you'll find a summary table with the contribution of each sources to the mix. Moving on to the transport sector, the dominance of fossil fuels is even more striking, with close to 91% of the mix, while biofuels represent around 8% of our demand and more than 85% of the renewables used in transportation. This once more underlines the key role that biomass currently plays and will still play in the future for the transport sector, especially when taking into consideration the fact that certain transportation means, mainly aviation or maritime transport, are either impossible or extremely difficult to decarbonize through any other renewable mean than bio-based fuels. And finally, we have electricity, which is the end use for which renewable represent the larger share with around 37.5%, while biomass represents around 15.4% of the renewable mix. In 2021, when considering all of these end use combined, we see that bioenergy represents 55.7% of the renewable mix and is therefore key for all types of end uses. I don't have to describe into a lot of details the energy crisis that we just faced. I think every one of you is aware of the problems that we have, and also highlighting the need to have an independent energy system in Europe. And so here on this slide, you can see the evolution of the indigenous energy production for the main fuels that we use in the EU. And so the colors here, they represent, so the gray and darker colors are fossil fuels, so coal, gas, and oil. The red one is nuclear energy. The yellow are all the other renewables. And finally, green is biomass. The first thing that we see with this graph is there is a general decrease of indigenous energy production from fossil fuels starting in 2005 already. As you can see, all of the 2021 values are below the 2005 values for most of the non-renewable fuels. And the tendency is the opposite when it comes to renewable. As you can see, biomass grew quite nicely, as well as other renewables. And there are here two important dates on this chart. So the first one is 2009. As you can see, in 2009 already, indigenous biomass production overtook indigenous natural gas production. And the second one is 2016. And it's in 2016 that indigenous bioenergy production overtook indigenous coal production. And now if we'd like to put this into perspective with our energy consumption, because here we've mentioned the production, we have another representation for this. So here, I know this is quite a packed chart, so let me walk you through this. So the colored bars here, they represent our energy production, and the gray bar in the background of each, they represent our consumption. And as you can see, the difference between the two is basically our energy dependency. And when we look at the first two bars, which are oil and gas, we can see that our consumption is largely outmatched by our production, is largely outmatched by our consumption. For oil, for example, we are 92% dependent on our oil consumption. We are 83% dependent on our gas consumption. When it comes to coal, we see that we have a much higher primary production in Europe, but still outmatched by our consumption, making us 37% dependent on coal. But the important part is now the last bar, so the bar on the right, representing biomass. Here you can see that the primary production of biomass is basically around the same level as our consumption, which makes us only 5% dependent on our biomass use, or 95% independent. And also here you have another chart appearing, this one representing our imports of energy. Here you can see that 57% of our energy imports are oil, 35% of our imports are gas, 8% coal, and only 1% for biomass, which is very interesting because while fulfilling around 12% of our total energy demand in Europe, bioenergy only represents 1% of our energy imports, which underlines the key role of bioenergy when it comes to the independence of the EU energy system. But now I'd like to move on to the second part of my presentation, which is going to focus and to go into more details on the role and the various uses of biomass for energy purposes. And I'm going to start this section by going over biomass in electricity. So as you can see here, we have a pie chart representing our electricity generation mix per product type in the EU 27 in 2021. And as you can see here, bioenergy represents, and also as I've said before, bioenergy represents 5.9% of our electricity production mix, or 15.4% of our renewable production mix. And this might not seem like something extremely relevant, but bioenergy does present very interesting characteristics when it comes to electricity production that we are going to need if we want to achieve climate neutrality by 2050. And this characteristic is that using biomass is completely independent to weather condition. So unlike other renewables like solar and wind, which unfortunately do not produce any electricity if the wind is not blowing or the sun is not shining, bioenergy can provide this constant electricity without any intermittency. And also an additional point when it comes to biomass in electricity, and when we compare basically the type of installations in which we generate the electricity, we see that for, let's say, common fossil fuel like coal, for example, only 29% of the fossil electricity that is being produced is produced in combined heat and power units. While when we look at the biomass share of electricity produced in combined heat and power units, this goes up to 74%, meaning that 3/4 of the electricity that we produce from biomass also produces heat that can then be re-injected and also serve the needs of multiple users like households or commercial and public services buildings through district heating systems, for example. Now, let's move on to the second end use, which is biomass in transportation. Here you can see the evolution of the renewable energy consumption in the transportation sector in the EU. And here, what I want to show is that biofuel represent more than 85% of the renewable transportation mix. And it also presents some very interesting characteristics, which makes it extremely important for the future energy mix, is that certain hard to abate transportation modes can only be basically decarbonized at large scale through the use of biofuels. And those are aviation, those are maritime transportation, which unfortunately cannot really be easily electrified. And last but not least, we have the use of biomass for heating purposes. This is where bioenergy, let's say, shines the most currently. So when we look at our current heating and cooling mix, we see that more than 3/4 of it is still non-renewable fuels. Biomass makes up 19.1% of this mix, and other renewables 3.8%. Which brings biomass at 83.6% of the renewable heating mix. And when we look now at basically who are the end users of this bioheat, we see that basically half of the bioheat that we produce is being consumed in households in direct use, so through wood stoves, pellet stoves, etc. And 1/4 by the industrial sector, and 1/5 by the district heating sector, but also serving the needs of other end users by re-injecting heat through district heating systems. And when we talk about the use of bioenergy in the residential sector, I have to make a clarification about the different types of uses that we have. It's the question of traditional bioenergy use versus modern bioenergy use. So when we look at traditional bioenergy use, mostly open fires, let's say, we have an average efficiency that is extremely low, under 30%, and we have emission of particulate matter. But on the other hand, when bioenergy, and this is what we promote at Bioenergy Europe, when we use bioenergy in recent appliances, we have an average efficiency that is around 90%, some variation, of course, depending on the type of installation, and also extremely low particulate matter emission, which makes modern bioenergy really a perfect type of appliance for households in the future. And now let's go over the advantages of using biomass for heat. So as I just said, using biomass in recent appliances, in modern appliances, is very efficient and a clean way of heating your home. And those solutions are commercially available. We don't have to wait in order to transition from traditional biomass to modern biomass. All of these solutions are commercially available. Biomass for heat can also be a standalone off-grid solution for remote areas that don't necessarily have a perfect connection to any types of grids, and can also help relieving some grid pressures, especially the electrical grid, when it comes to high demand times. Indeed, grid pressures or grid technologies have been identified as one of the largest bottlenecks of decarbonization in Europe. And we do start facing those issues, and the use of biomass for heating, especially in the winter, can help relieve some of the grid pressures. As I said as well, using biomass and also for heat provides energy no matter the weather. So it's not an intermittent source of renewable heating. And it's also basically the only renewable heat solution for a certain application, especially for industrial ones. So high industrial heat, such as in the lime or the cement industry, for example. But we do acknowledge that, some of the uses, like, for example, using biomass in traditional bioenergy appliances is not the way to go. So we do have some opinion on what the way forward should be. And the first one is that there is a need for policies and incentives for the replacement of those outdated, inefficient, old appliances for new ones. And also we need some better efficiency measures, because those would not only help, let's say, improve the air quality by reducing the amount of pollutant that can result from poor quality fuels used in open fires, but also if we have more efficient appliances, to produce the same amount of heat, we need less biomass. And this then also helps us a bit on the supply side. And also it can help us fight energy poverty. Here, as an illustration, this is the distribution of houses per energy sources and per income class in Hungary. And here what I want to show is that, so first off, the income class 1, on the left side of the slide, are, let's say, more sensitive, poorer households. And income class 5 is, let's say, richer households. And as you can see, the contribution of wood is extremely different depending on the income class. So on the income class 1, the use of firewood is basically in half of the houses. While in income class 5, it's only 1 out of 5. And therefore underlining the crucial importance of bioenergy and for biomass in the crucial importance of biomass in heating for sensitive and poorer households. Also, we need a better recognition of biomass and the role it has to play in the future energy system if we truly want to reach climate neutrality by 2050. And we also need a better consideration of the needs of the end users in future policies. I can speak from experience here. I've attended multiple projects, especially on industrial decarbonization, and sometimes it seems that there is a bit of a mismatch between the expectation of the industrial players that have to decarbonize and the people making the regulation behind. And so this, we really need to make sure that these are aligned in order to make efficient policies. Now let's move on to the third part of my presentation, which is going to be a conclusion and some key messages. So the first one that I hope all of you got is that most of our energy demand is actually for heating purposes. And therefore, this cannot be forgotten in any of the decarbonization talks. We do need to address this issue of decarbonization of the heating sector. At 55.7% of the renewable energy mix, bioenergy is by far the largest renewable energy source in the EU. And also, it's a local resource that works towards the EU's energy independence. Also, that biomass and electrification are complementary and not competing against each other. And bioenergy also presents some unique characteristics that we will need to achieve true climate neutrality, like being able to provide high heat for industrial needs, or being able to work without relying too much on the grid. And last but not least, that biomass is a crucial energy source for households, and especially for more sensitive and more poorer ones who don't necessarily have the capacity to react financially to an energy crisis. Thank you very much. I hope that my presentation helped you understand the role that bioenergy plays in the EU's energy system. And now I would like to give back the mic to Anna to introduce our next speakers. Thank you.